Chapter 17.6 Using Bayes' theorem to calculate posterior probabilities. In the last section, I promised to show you how posterior probabilities could be determined from prior probabilities. In that section, we define the following events for the Gimbal department store example. SD is the strong demand for dresses has occurred. WD is the weak demand for dresses has occurred. SSR is survey result predict strong demand. WSR is survey result predict weak demand. The prior probabilities were defined as P of SD equal to 0.6 and P of WD is equal to 0.4. We'll use these prior probabilities to determine the following posterior probabilities. That is the one you are given in the previous section. Recall that if the market survey predicts strong demand for dresses, the posterior probabilities of strong demand and weak demand occurring are probabilities of SD given SSR is 0.84 and probability WD given SSR is 0.16. Recall to from the previous section that if the market survey predict weak demand for dresses, the posterior probabilities of strong demand and weak demand occurring are probability of SD given WSR is 0.36 and probability of WD given WSR is 0.64. How could you have determined this posterior probability if I had not given them to you? To convert prior probabilities to posterior probability, we need some additional information. More specifically, we need to know the effectiveness of the market survey. Suppose that historically the market research firm has correctly predicted strong demand 70% of the time and incorrectly predicted strong demand 30% of the time. This can be expressed as the following conditional probability. Probability of SSR given as SD is 0.7 and probability of WSR given SD is 0.3. We also need to know that historically the market research firm has correctly predicted weak demand 80% of the time and incorrectly predicted weak demand 20% of the time. This can be expressed as the following conditional probabilities. Probability of WSR given WD is 0.8 and probability of SSR given WD is 0.2. We are now ready to use Bayes' theorem to derive our posterior probabilities from these conditional probabilities and the prior probabilities given to you in the previous section. In Chapter 4, I introduced the formula of Bayes' theorem, which is shown again in equation 17.5, where AI is the ith event of interest from a choice of an event. B is an event that has already occurred. Bayes' theorem is needed because we have to convert a conditional probability such as probability of SSR given SD to the posterior probability of SSR given SD. Rather than use equation 17.5, we will do the necessary calculation, the result of which are shown in table 17.13 and 17.14. Table 17.13 calculates the posterior probabilities for the scenario in which the market survey predicts strong demand. Column 2 and 3 represent the prior and conditional probabilities that we started with. These two columns are multiplied together to calculate the joint probabilities shown in column 4. When column 4 is summed, we have the probability that the market survey will predict strong demand, or the probability that the market survey will predict strong demand, or PSSR, which is equal to 0.5. Recall that this was the probability used for EMV1 and the decision tree display in figure 17.10. Column 5 shows our final result. The revised probabilities for strong demand and weak demand, given that the survey predicted a strong demand. These probabilities are found by dividing the joint probabilities by the sum from column 4. Notice that these two posterior probabilities match the value used in figure 17.10. We follow the same steps to calculate the posterior probabilities for the scenario in which the market survey predicts weak demand. The results are shown in table 17.14. The sum of the joint probabilities in column 4 represents the probability that the market survey will predict weak demand, or PWSR, equal to 0.5. The posterior calculation for column 5 are as follows. Again, this value match the one we used to evaluate the decision tree in figure 17.10. Thank you.